Okay, so I just wanted to talk about real quick what I wanted to get to in class, but that we weren't able to get to, and that was natural logs. Okay, so usually when we have our logs, we have a base number in this small area. So right here where this E is, well, in some cases we have an E there instead of a whole number. So we're going to be talking about those types of functions moving forward. These are natural logs, base E. E is an irrational number. It tells us what it equals right here, 2.71828, blah, blah, blah. Since it's irrational, it continues on forever and ever and ever. And they usually use it, like it says here, to describe real-world phenomena. Okay? So, if we have this, we're going to add this to our foldable tomorrow, but natural log of x is the same as log base E of x. So those two are equivalent to one another, and there is a natural log function on your calculator that you can use. Let me grab mine and I'll show you really quick where that's located. So all it means is that it's a base E and we can convert it to a natural log. Just another rule that we can use when evaluating these types of things. So natural log is found on your calculator right near the logarithm button, right under it. And you can see that if we use our second function and press ln, we're going to get an e to the x power. So if we're trying to find the natural log of something, all we have to do is press our ln function and then type it in. So right here it says use a calculator to evaluate this. So I would just type in the natural log of 1685. And you can see that that matches up with what the book's given us here. Okay. The second thing that you're going to have to do when it comes to natural logs is just convert e to the whatever into a logarithmic equation so that we are able to evaluate it. So if we have something where it says e to the 2x equals 7, we're just going to convert that back into our logs using our log rules. On our foldable, that log rule, I can flip to it here, is going to be our old switcheroo. So our base stays the same and our two numbers switch. So in this case, our base is going to stay the same and become the log of e, and our two numbers switch. So 7 is going to come over to this side, and the 2x is going to go over to the other side. So we've used that before, just not with the base of e. And you may be wondering, well, why is it even helpful to convert something from this form over into the logarithmic form? And the answer to that is right up here. We are able to convert our log e to the x back into a natural log. So now that we have it in this form, we can convert it to ln. So log of base e is going to equal ln. So we could say ln of 7 equals 2x and go from there. Also, when we get it into this form, we are able to use our rule here. So the two things that I just want you to take away from this extremely brief lesson is that we can use the calculator to evaluate natural logs by using this button here, ln. And we can convert our base e's back into logarithms using our switcheroo rule that we wrote on our foldable. And that's helpful because it helps us convert it into a natural log. So I'm going to do a couple of those with you and then let you loose to do a couple. Again, like we talked about in class, the couple of questions that I give you, I want you to do in that notebook that I gave you. And then you will turn it in tomorrow. We will be going over them. It'll be a simple notebook grade. So this one says use a calculator to evaluate each expression. Well, that's easy enough. All we have to do is press LN on our calculator, and it asks for the natural log of 732, so we just plug that in there. So number 1 is going to be about 6.6. Where does it tell us to round it? 4 decimal places. Well, I didn't do that. If it was 4, it would be 6.5958. Alright, so that's how we do those with calculators. Something keeps popping up on the screen. Okay, so this is asking us to write an equivalent exponential or logarithmic equation. So right here we have a base of e. If we switch that to our logs, we're just going to use our switcheroo rule that we used with normal logs. Our base stays the same, and we switch our exponent and our answer. So the x is going to come to this side, and our 15 is going to come to the other side. And again, why do we do this? Why do we turn it back into a log when we've tried so hard this entire time to take it out of a logarithmic form? Well, it's because log e is equivalent to a natural log. So this would then become the natural log of x equals 15. We see that type of problem here when they give us a natural log and it wants us to go the opposite direction. We know that a natural log is equal to log base e, so we would turn it into log base e. And then all we would do would use our loop-de-loop rule, which again is on our foldable, to turn that back into an exponential function. So we would do e to the x equals 20. So the natural log of 20 equals x is equivalent to e to the x equals 20. So we're just using rules to flip back and forth between different forms. We will be talking about evaluating more in class tomorrow. So I want you guys to focus on these type of problems today so that we don't have to worry about converting in class. I can answer any really important questions that you have, and then we can move on to the harder stuff like evaluating. So what I want you to do in your notebook is to use your calculator to estimate number 2. And then I want you to do number 13, convert this back into your natural log form, and you're going to convert your natural log form back into your exponent form. So this one, you start by using your switcheroo rule to get it into a natural log form, and from here you convert it into a log and then use your loop-de-loop rule. So those 3 problems is what I want from you tomorrow morning for a notebook grade. Number 2, number 13, and number 14. So pause this and get those down in your notebook or on a scrap piece of paper for those of you that weren't in class today so that you can do those. And again, tomorrow we will move on to evaluating expressions using this inverse property. All right, I will see you guys tomorrow.